Okay, can everybody see my screen? Great. All right, well, thanks everyone for joining us tonight. Our main talk tonight is going to be Paul Sheriff giving us a talk on cryptography. I like the aspect that he has made easy inside of this title. So I'm definitely looking forward to this. I need this. And also Lindsay from Adaptive Solutions, Lindsay Trammell. So Adaptive Solutions is sponsoring us tonight, as well as giving the lightning talk on virtual interview tips. So Lindsay, I'm going to turn it over here shortly, and that way you can kind of share with what the giveaway is, and then you can go right into your talk right after that. And I also want to share a couple of the other upcoming meetups before I turn things over. Next month, Robert Bodenheimer is going to give us a talk on making the web faster. And I've seen actually Robert speak before. He gives some great talks, and this is one you do not want to miss. And let's see, in May, Jeffrey Palermo is going to come back. He's going to give us the talk on Azure DevOps for .NET fall into the pit of success. It's easier to read that title than it is to say it for some reason, but that should be a good one as well. And I was actually exploring Jeffrey's site, Clear Measure, and there's actually a lot of great content out there as well. So highly recommend checking out what his company has to offer. And in June, Architect Now is going to be giving a talk. I'm not sure what that's going to be just yet, but it might be the July-August timeframe. I was talking about this with Paul earlier. Hopefully we'll be in person around that time. We'll see. Otherwise, we'll keep doing what we're doing remote as the I guess you'd say as the pandemic pretty much winds down. The recording tonight will be posted up on YouTube, and we've been doing this for the past so many months. And the best way to actually find these recordings, you can of course search for the St. Louis.NET Meetup on YouTube, or actually in the event itself. So for example, last month when Jeffrey gave a talk on Blazor architect patterns, I do post a link to the video in the comments for each one of these meetups that we record. So I'll be posting the link in this meetup later on tonight, tomorrow. And last, I want to share the Minnesota Developers Conference is taking place on May the 4th. I attended this conference last year remotely, and it was a really good conference. They did a great job handling, all the remote aspects. They did a great job. So highly recommend it. There's a lot of speakers, a lot of sessions to check out there. You could simply search for Minnesota Developers Conference and find this. All right, I am going to stop sharing my screen. And Lindsay, I want to turn it over to you.
Thanks, John.
Thank you.
Hi, everyone. My name is Lindsay Trammell. I work with Adaptive Solutions Group here in St. Louis. If you have not virtually met me in the past couple meetups here, Adaptive Solutions Group is an IT staffing company headquartered here in St. Louis. We're over in Creve Coeur. We work with a lot of the big Fortune 500 names here in St. Louis on contract and direct placement positions. Just kind of a brief overview about us, but we work on a lot of development positions, .NET especially. I'll put my contact information in the chat here as always. So if you are in the market, know someone else in your market, please feel free to give me a call, email me. I would love to chat with you about the St. Louis market. But outside of that, we are sponsoring tonight's meetup. We're doing another giveaway. I'm going to send the link here in the chat, but I'm going to share my screen as well. We are giving away this really cool laptop. I hope you guys can see it here. Here we go.
Yeah, I see it.
This laptop backpack. It's really cool. It's got a lot of different features. It's anti-theft. It's waterproof if you're getting out there with your laptop. It's obviously great for going into the office, but it's actually designed to meet a lot of needs if you have any hobbies. It's also great for art supplies, camera supplies, but also your typical laptop and work supplies as well. That's at an $80 value, and that is what will be up for grabs tonight. So when I put my contact information in there, if you'd like to enter to win the backpack, just send me your name to that email address and you will automatically be entered into a random drawing, which I will announce tomorrow, and then I'll contact you individually to get your information to send that your way. And let me know if you have any questions about that product either. But on to the lightning talk. So tonight I wanted to share with you guys just some basic tips for remote interviews. Most places these days, at least first round, are doing video interviews, which some people have done in the past, but some people it's totally foreign. So I wanted to just share some good tips from a recruiter's perspective on what you can do to kind of help prepare for these. If you want me to send you a copy of the information I'm going to talk about, feel free to reach out. I didn't want to, put something up and just read to you. So I wanted to make it a little bit more conversational, but I'd be happy to send you any info afterwards as well. But to get started, I just kind of wanted to preface as saying, with Zoom interviews, any remote interview really, you should be basically preparing for this, treating it the same way that you would an in-person interview, if not more carefully than you would in a regular interview. Just because it's virtual by no means means that it's, an informal interview. It definitely should be treated just as formally, from how you present yourself to how you prepare to how you are dressed, obviously. Honestly, more things can probably go wrong on a Zoom interview than they could in person, as far as other things going on in your household, your internet connection, your sound, different things like that. So you would just want to make sure that you're really prepared for anything that could come up, and make sure that you can stand out in a positive way among interviewers. It is a little bit tougher, I think, to make an impression, especially if they're doing multiple video interviews a day. Every single person is just somebody on the screen. It can be a little bit harder to gauge someone over a camera versus in person. So just make sure that you're keeping that in mind with every kind of step of preparation that you do. Some of these tips are more relevant if you're working with a recruiter on the position. If you're doing it by yourself, obviously there might be a little bit more extra steps that you need to take. But my first major tip would just be to make sure that you're researching the company. If you are working with a recruiter, they'll probably send you a link to their website. But go the extra mile and ask them about the hiring manager. Have you guys placed somebody on this team before? Do you know what his interview style is like? Do you know, what has stood out to him about candidates in the past? Another great thing to ask is what their dress code is on a day-to-day. Sometimes recruiters or people in general get the idea that they should wear business formal, business professional wear to an interview. And a lot of times that's the case, but maybe you're interviewing somewhere like Anheuser-Busch, for example, where the typical dress code day-to-day is jeans and a polo. Not that you want to wear that to the interview, but you also probably wouldn't want to wear a suit and tie to that interview either. So just things like that, just trying to make sure that you understand their culture and what the hiring team is like as much as you can prior to that interview. If you don't know anything about their culture, just because that's not something that's typically on their website, I would err on the side of business formal if you can, at least a shirt and jacket, if not a tie as well. Etiquette wise, there's a lot of things that, like I said, can come up on a remote interview that you might not be thinking about until it's 5 minutes ahead of time. You should be receiving a link to your interview, obviously ahead of time, most of the time days before, if not hours before. Make sure that you are testing out that link. A lot of times you'll think that you can just click right into the video, but it's 2 minutes to your interview. You click that link, you realize you have to download an application. You have to allow permissions to your video and camera. You don't have the right kind of internet extension, something like that. So I really suggest playing around with that link. It won't mess anything up if you try to enter the room early. Nothing like that is going to happen. So make sure that you understand if it's Zoom, Teams, what kind of platform you're going to be dealing with. And then obviously make sure that if you are going to be on video, your background is going to be professional. It's going to be quiet. It's not going to be distracting. You can plug your computer in so it's not going to die. Just little things like that sometimes don't pop into your head until you're scrambling to get on the link and might make you a couple minutes late. That being said, if you do have all that stuff prepared, I would suggest dialing into those calls 5 minutes early if you can, just to, again, avoid any of those kind of technical difficulties that come up. So what you can sometimes run into, especially if you're in using a platform that has something called like a waiting room, something like that. If something does go wrong, if it's been 5 minutes and no one's joined, I would make sure that you are reaching out to your recruiter, or if you have contact information for someone that set up the interview, I would reach out to them right away just to make sure that the problem's not on your end. You'd be so surprised how many times I call someone to get feedback on how their interview went, and they said I sat there for 20 minutes and waited and nobody ever got on, so I gave up. And they never reached out, never let me know. That's something that we probably could have salvaged in a couple minutes if you'd reached out. So another good tip would probably be to have that contact information ready to go should anything go wrong and you don't know if it's on your end or if it's on the hiring person's end. And then outside of that, just in the interview itself, obviously your typical kind of interview advice would be, to have questions prepared. You want to do that still, obviously, like you normally would. But something we might forget to ask about is, asking about their COVID contingency plan moving forward. Are you guys in the office right now, but remote calling me? Are you guys at home? When do you plan on going back? What does that look like? Is it going to be on a rotation? They might be remote right now, but they plan on going back in May, and now you have a commute that you hadn't considered prior. So just make sure that you are applying the current environment with COVID to the questions that you're asking in that interview. On top of that, just, again, some things that you would probably have thought about for a typical interview anyway, but just making sure that you show that you still did your research on the position, even though you're not meeting these people in person. They still want to know that this is obviously a priority for you. That being said, making sure that you're not just looking at their website and knowing what they do, but knowing how the position fits into their organization the best that you can, and what kind of different verticals it's going to be affecting. That'll just make it easier, obviously, for you to understand the role, but obviously for you to also relate your previous information affecting those kind of business verticals in the past, if you have done that. Another thing that I thought would be helpful, especially if you're using these these platforms a lot. I use Microsoft Teams every day for work, for example. But if you're able to, try to see if you can call a friend or a current coworker using that platform prior to your interview to make sure that your sound is working okay, that you can sit this far back and still have them hear you, that you can test the video screen to make sure that it's the angle that you want. It's not showing anything that you don't want to show. Just be as prepared as possible for anything and everything to go wrong on that Zoom call, as we all know sometimes happens. To go off of that, something I wanted to make sure to say is please wear professional top and bottoms. I know most scenarios it's just going to be shoulders up, but you never know if you might have to stand up to replug in your computer or whatever could go wrong, and they realize that you're wearing sweatpants or something even more informal. But make sure that you're dressing like you would for an in-person interview and treat it with as much preparedness and professionalism as you would normally. If anybody has any other questions, please let me know. Like I said, I'm going to put my contact information into the chat here. Email me your email address if you would like to be entered in the drawing. But like I said, also reach out if you're in the market, or if you have any questions about our giveaway or questions about any of the material that I went over for remote interview tips this evening. I guess I could take any questions if anyone has one right now, John, but I don't know what you need to get onto.
I was going to say, if anybody does have any questions, why don't they go ahead and put them in the chat, or feel free to chime in. Actually, I do have a couple questions.
Okay.
One of them is when so the dress, when you're at home, it does feel a little weird to put a suit on. So even though when you would go into an office for an interview, it kind of feels normal, I guess, to wear a suit to an interview.
Right.
Do you find that when it comes to that, having the suit and the tie, at home for a virtual interview, is really not needed, or did you still suggest doing that?
Kind of like what I said, if you're able to, especially if you're working with a recruiter, they should have a lot of insight on what that particular company's culture is. For example, where I used to work, the boys had to wear a suit and tie every single day. But then again, one of our clients, Anheuser-Busch, as an example, they wear jeans to work every day. So us showing up there in suit and ties, they'd kind of give us crap for it. So that's why I think you should just try to reflect the culture of the group that you're interviewing with the best that you can. I don't know that a full suit and tie is going to be necessary every single time, but at the very least, a button down, if not, just a collared shirt with a jacket, something like that. You'd just be shocked how many people think because it's a remote interview, they can get on in a t-shirt and that's fine, which is just not the case. So just err on the side of more formal than you usually would be is the best advice I can give there.
And pants.
And pants, please.
So also on the virtual side, a lot of people starting to use those virtual backgrounds. What kind of advice do you give on doing those or having a virtual background?
If that's something that you have done previously and you know that it works well on that platform, if you do that every single day on that platform for your work, then I think that's totally fine. If you're not able to kind of find that spot in your house that would be more professional, I would not suggest testing that out for the first time on an interview. It can get really spotty. It ends up just being really distracting. You might continue to be like pixelated out. So if you're able to test it out or that it works for you already, go for it. I think that's fine as long as it's professional. I don't need to interview you while you're like on a virtual beach, but something a little bit more low key than that is fine if you know that you're comfortable using that technology.
Okay. Yeah, and any horror stories?
Like I said, people, they think of it as, since I'm at home, I don't need to, treat this in a professional manner, which sounds silly, but, some people just don't think things through all the way sometimes, which happens. But like I said, it's harder to make an impression if they're interviewing a number of candidates over Zoom. So just make sure that you're standing out in a positive way and not in a negative way. Try to be the most prepared professional candidate that they've spoken with that day. The same as you would if you were in person, just requires a couple more preparation steps. So no t-shirts, don't let your computer die. Don't try to blame a bad internet connection. Just do your due diligence.
Yeah. Well, thank you. Thanks for the tips.
Absolutely.
Of course, put your info in the chat. And you want people to email you, right, for the drawing?
Yes, if you want to be entered into the drawing for the backpack, just send me your email address. But like I said, feel free to reach out to me for any other needs as well.
Great. That's a pretty cool giveaway. I was expecting just a gift card, but this is better.
We tried to do something a little bit more creative for you guys, so I hope you like it.
Yeah, that's cool. All right, Paul, you ready?
Absolutely. Hey, I was going to say something because I did about 65 interviews last year for this company.
Wow.
I actually helped them hire people. And boy, I can relate to a lot of those stories. The main thing to me is try to get to some place. If you're going to have kids screaming in the background, dogs barking or anything, if there's anything you can do to muffle that or send them out for the day, that was so distracting. I had that happen on about 10 of them. And one of them, the wife was actually screaming at the top of her lungs for the kids. No. So, yeah, the guy was really embarrassed, but, he should have made sure that happened before he went on this call and said, take the kids out. So,
yeah, an at-home interview should be a family event. It should be on the calendar for the whole team.
That's right. There you go.
Great. Well, thanks, Lindsay.
Thanks, John.
Paul, you ready to take it over?
Absolutely. Let's see. Oh, wait a minute. Hold on. I got the wrong desktop here. I'm going to which one? That one. There we go. Okay.
There you go. I see it.
All right. You can see my PowerPoints and everything, right?
I see. Well, it's not really painting right. I haven't seen this before.
Okay. Hold on. I had this problem before. I hate Teams personally.
Well, it is sharing Studio. It's not showing PowerPoint.
Oh, all right. So can I?
You might be just sharing Studio as an app.
Ah, there we go. I can share screen one. Okay.
There you go. I see a blue screen.
Blue screen. Give it a second. Nothing.
Just see your background. Yeah, I don't.
Oh,
Just see your desktop.
Okay. Well, then, all right. Hold on. Sorry. All right. Let's go with this one here.
There you go. I see PowerPoint itself.
Great. All right.
Deck.
Yeah, I think it did the app instead of the screen, so that's happened. All right. Cool. All right. So, whoop. Now
we see. Yeah. Now we see.
I know. I hate this crap. God, just swap them. There we go.
All right, all yours.
All right, guys. So, well, thank you all for having me again. So my name's Paul Sheriff. I'm a business technology consultant. I've got over 35 years of IT experience. I'm a software consulting business owner for over 30 years. I actually ran a consulting company for many years with lots of employees. I sold that about 4 years ago now. Wow, yeah, 4 years ago. So now I'm just a writer, a speaker, a consultant, a mentor. So I'm also on Pluralsight. If you guys, I know a lot of you are probably on Pluralsight. Check out my courses there. I just released a brand new one on Link. So check that one out. I got many on JavaScript, Angular, C#, all sorts of different topics out there. You can get a hold of me at psheriff@pdsa.com, and you can hit my website at pdsa.com. Also thought I'd mention that coming up, I'm doing a 2-day hands-on training seminar. I'm sure a lot of you have heard of VS Live conferences over the years, and they have now switched obviously to more of a, an online presence until they can get back to conferences, which they're hoping to start in December or November. I think November it is. But I'm doing a 2-day hands-on building your first .NET 5 MVC application. So if you're interested in that, it's May 4th and 5th. 2 days, no MVC experience required. I'm kind of assuming you don't know anything about MVC, but even if you do know a little of MVC, this is on .NET 5, and there are a lot of differences from the .NET framework. So if you're still on the .NET framework, this might be a good one for you to attend. And so here is the link here that you can go and check that out. It is not free, by the way. I've had that question before, so but it's not terribly expensive for a 2-day hands-on. So, all right. So I'm going to turn off my camera. You all don't need to be looking at me while I'm doing this. So for this talk tonight, cryptography made easy. I'm going to just assume that you're familiar with .NET, that you're familiar with C#, and you're familiar with Visual Studio, and that you're kind of interested in learning how to hash and maybe encrypt and decrypt data, and maybe store some keys. So that's what we're going to be going over tonight. So we're going to first cover out, I'm first going to do a few PowerPoints up front here. I'm not a big fan of PowerPoints. I don't do a lot of them. I probably have more in this one than I've had in a while because I find people need a little bit more introduction kind of on the security stuff. So we're going to go over some general security concepts first. We're then going to dive into hashing algorithms. We'll take a look at symmetric algorithms. And oops, I'm sorry, I missed a bullet point there. I'm also going to take a look at key management. We'll use the DP API for that. All right. So everything I'm going to do tonight, by the way, I'm using Visual Studio 2019, but I am using .NET 5. So the things I'm going to talk about tonight are mostly for .NET 5, although the majority of it, I believe, yes. In fact, I can only think of one thing that might be a little bit of an issue. It actually might be easier to use in the .NET framework as well. But everything tonight should actually work in both. But I am going to be using .NET 5 tonight. But let's talk about the goals of cryptography, right? I mean, first of all, we could do confidentiality. You're trying to protect a user's identity, protect data from being read by an unauthorized person, for example. Data integrity. You want to ensure that data has not changed. Might be another reason why you need to use cryptography. And we'll see some examples of a lot of these as we go along. Authentication. You're ensuring data is guaranteed to be from a particular party. And of course, non-repudiation. Prevent a party from denying that they sent the data. So if you think about each of these that I talked about here, right? I mean, a lot of this you can think of like SSL, right? SSL is a perfect example of using cryptography, and almost every site today, they should be using a secure sockets layer certificate, right? To make sure that all data sent back and forth is encrypted and decrypted. So that way there can be no man in the middle attack, right? Okay. If you think of non-repudiation, for example, prevent a party from denying that they sent the data. Anybody ever used DocuSign? Okay. That's a kind of a good example that, hey, I signed that, so you had to log in. They're the authorizing people that say, you know, hey, we kind of verified that this guy is who he says he is, and, you know, they can do that several ways. So these are some of the things that use cryptography all the time. Let's talk about the different cryptography types. So there's a few different types that we're going to look at. There's 4 basically, but symmetric key. Now this is what's also called a secret key. This particular algorithm is good for sending large blocks of data. Now symmetric and asymmetric means that you can both encrypt data and decrypt it on the other end. So symmetric is what's called a secret key algorithm, good for sending large blocks of data. And they have things like AES, Advanced Encryption Standard, RC2, Reindl, DES, and triple DES. So these are some of the examples of some of the specific algorithms you could use when you're doing symmetric key algorithms. Asymmetric means you have to have a public key and a private key. So symmetric key basically is one secret key. With asymmetric, you have a public key that's used to encrypt the data, and the private key is used to decrypt the data. Now, this is generally used to send small blocks of data. For example, sending a secret key out would be an example of using an asymmetric algorithm. And for these, we have these algorithms such as RSA, ECDSA, EC Diffie-Hellman, and DSA. These are some examples of the algorithms that you'll find built into .NET. Now, just because I'm mentioning these here doesn't mean there aren't other algorithms. It just means that these are the ones that are built into the .NET framework that you can take advantage of. Now, we also have hashing. Now, hashing is a one-way algorithm, and I'm sure a lot of you have probably experienced this before. This is where there's no way to get the original value back, and where you may have seen it before is it's frequently used to store passwords. So for example, when you use like the security system built into .NET for like MVC or in the old days web forms, they would let you choose, did you want to be able to encrypt and decrypt and get the password back, or did you want to just hash it? So this hashing means that, hey, you're going to store that password into the database, right? Like SQL Server or Oracle or wherever you're going to put it. And it's going to be stored in that database in an encrypted format so that if somebody were to crack that, get to your SQL Server and look at that table, they wouldn't be able to see immediately what that password was. And some of the algorithms that used to be used were things like MD5 and SHA-1. These are not secure algorithms anymore. They've been proven that they can be broken too easily. So the recommended ones today are SHA-256, SHA-384, and SHA-512. Now we also have digital signatures. This is a form of asymmetric, or a public key encryption is what those are called. This helps us verify the identity of a sender. Okay, so again, RSA, ECDSA, and DSA are examples of a digital signature. All right, so what do we have in .NET? It's a little confusing if you go up and you start reading. I mean, John and I were talking about this at the beginning, of the talk, because he said, I'm glad you're saying made easy, because if you've ever gone up and tried to figure this stuff out by reading Microsoft's documentation, it can get a little confusing. Although I found their latest documentation is much better, but there's all these things. They have these crypto service provider classes. They have CNG classes. They have managed classes. So I put the asterisk in front of it because it may be like DES Crypto Service Provider or AES Crypto Service Provider, AES CNG classes. Okay. So they've got all of these different kinds of things. They're basically wrappers around basically that APIs that are built into Windows. So there's a cryptography API built into Windows. Okay. And then there's also this cryptography next generation APIs that they came out with as well. And I'm going to talk about that in a second. Okay. And in managed classes, these are written entirely in managed code, but if you're going to be working with the federal government or any government entity, and they're going to require a certain amount of standards, okay, they have a FIP standards, you're not going to be able to use the managed classes. You will have to use the crypto service providers or the cryptography next generation APIs. Oops. Yep, there we go. So what's in .NET Core and .NET 5 are all of these crypto service provider, CNG, and managed classes. So you can use any of them. They're all wrappers, though, around the operating system. Now remember, .NET Core and .NET 5 are for cross-platform, aren't they? So what they needed to do is they had to make sure that they could write these providers one way, and then they did a mapping layer on whichever operating system they are using. Now, this does not guarantee that all operating systems are FIPS certified. So you got to be careful what operating system you're running on. Again, if you're going to be doing government work and you do need to do, encryption, decryption, or hashing or anything like that, right? You will have to make sure that the underlying operating system that you're running your .NET Core, .NET 5 application on support these managed or these classes, these crypto APIs that are FIPS certified. Now, what they've done in .NET Core and .NET 5, which is really neat, and actually in the .NET Framework too, they added this to the latest version. I think it came in 4.7 maybe, but they added a create factory for any instances of these algorithms. What's great about this is you don't need to worry about crypto service provider or CNG or managed classes. You don't have to worry about which one's going to be chosen. The create factory is the create method, that factory method is going to pick the best one for you to use for that particular operating system, which is great. And that's what we want to do. All right, so let's dive in and talk about hashing first, and then we'll get into encryption and decryption. So hashing. What we want to do is create an instance of a specific algorithm. So you're going to choose which one you want to do, an SHA 256 or an SHA 384, for example. And you'll write this line of code that you see. It's SHA 256 ALG, variable name, equals SHA 256 dot create. That's all you got to do. And it'll give you back a real instance of whatever that underlying API call or hookup that they're using for that OS. We then have to call the compute hash, and we take our value, like a string value that we've passed in to hash. We convert it to bytes and pass that to the compute hash, and it gives us back a byte array of this hashed value. Now, this is interesting. If you go and you were to look up on Microsoft's website and you see some of the sample code there, you won't find the clear method in there. But in the remarks, it clearly says that you should call the clear method prior to the object being disposed, but they don't put it in. So I'm always a big fan of, making sure I'm very well protected. So I'm going to do what they said in the remarks, and I'm going to add the clear. So you'll see that in my code. Now, if you want to take this hashed value and maybe you're going to store it into your database or something, right? Okay. What I might do is convert it to a base 64 string. That way I can just store it as a string in a varchar field in my table. Now, I know a lot of us before we use something like SHA-1 or MD5 or something like that. And in fact, that's what Microsoft used a lot of times underneath the hood in their security system. And they created remember they created that ASP.NET user table if you've done web development, and it had, a password size, and maybe it was like, they might have done it at 100 or something. Well, now you're going to have to beef that up. It's going to have to be at least 256, if not more, depending on the algorithm you're using to hash that data, because it's going to come back as a big long string. The bigger the better, right? Okay, that makes it just that much harder to crack. All right. So as I kind of promised, I don't have a lot of slides. I just have a few more here and there, but let's go in and take a look at some demos. All right, so what I've done, so I'm using the latest version of Visual Studio 2019, and what I did is I went in, I created a new project, and I created a console application. So I'm just using the console application tonight. I'm independent of any, so I don't care. You can use this cryptography stuff in WPF. You can use it in, MVC, whatever you want. It doesn't matter. You could use it in web forms, Windows forms, anything. I'm just going to use a console app. And I don't know if you've upgraded to the latest and greatest, but one of the nice things now, I'm going to go ahead and finish this, but you can see that they now tell you what target framework you want to go to, which is nice. So you can see that they now have the, the current long-term support ones in there only. So 2.1, 3.1, and of course 5.0. All right, I'm not going to finish this, but I just wanted to show you this is how I created this sample. I will give you the URL to these samples at the end of the course here. All right, let's take a look at our first one that I did. So I created a hash view model class here. And I then created this little guy called hash using SHA-256. So what I'm going to do is in my program, I'm just going to create an instance of this hash view model. And what I'm going to do is I'm going to call this method hash using 256, passing in some value. That value is password. So one of the most commonly used passwords out there. So please don't use this for your password anywhere. All right. So let's take a look. We pass that password in here as a string. So I'm going to return a string back after I've hashed this thing. Let's take a look at what I do. So first thing I'm going to do is I'm going to have a return value coming back. I'm then going to use a using. And I'm going to do that SHA-256. This is a class that Microsoft has available, and it's in the system.security.cryptography namespace. So in order to use these, you will want to be bringing this namespace in. Then you have access to all of these great little things like SHA-256. And then all you have to do is use this create here. Right? So the create is a factory method, and it will go out and get a concrete instance of 256 for us to then use. Now, you remember I passed the value in, the value being password. So I'm going to take that. I'm going to go ahead and convert it to bytes. And I'm going to pass that then to the compute hash that's of this algorithm. That's the method. And it brings me back a byte array. And then, as I said, what they said in their remarks, but you won't find it in all of their samples. There were a couple I think I saw up there. But you want to make sure you're clear. What this does is this gets rid of any sort of keys or anything that they use to calculate the hash of this value. So it clears all that out from memory, which is great. Okay, because you remember how the .NET framework disposes, right? When things go out of scope here in this using, when this algorithm goes out of scope, does it immediately get released from memory? No, it just goes in and it stays out there until what? The garbage collector finally comes along and says, oh, I can now get rid of this algorithm object. Okay, but until that time as that gets gone, right, by the garbage collector, that thing is still around. So that's why they want you to clear. That will actually clear out the memory. Even though the object isn't gone, it's going to clear out that memory of where it used to do this hashing. All right, so then we're going to convert our password that we hashed now. We're going to take this byte array and we're going to convert it to a base 64 string, and that's what then gets returned. All right, so now if we then were to go here, I'll set a breakpoint. And let's run this. Okay, Let's close this down. And let's step into this. All right. So we're going to create an instance of our hash view model. We're going to take that value password, and we're going to now send it through our routine. So we can watch it do this. Okay, so now we have this byte here. All right, you can see all these bytes. Okay, it's 32 long. We're going to clear, and then we're going to take that and we're going to convert it now back into a string. And that's what we'll then write out here into our console. So let's go ahead and just hit F5 and we'll run this. So that is the 256 hash of password. You see how long that is, right? That's quite a bit longer than that. But this is great because that means that somebody who were to look at this and we're going to try to reverse engineer and figure out what it was, they'd have a very difficult time. All right. Now, one thing, so try to remember this value right here, right? SG17CO. If I run this again, I'll just hit F5 and let it run. We get the exact same value every single time, right? The reason I'm pointing this out is I want you to think about if you have a SQL Server database and you have the ASP.NET users table out there, okay, or whatever user table you have. In there, you're going to have maybe, 1,000, 2,000, 10,000 users out there. And if you have their username and their password, even though it's hashed, let me ask you something. What's the odds out of 10,000 people of 2 people using the same password? Probably pretty good, huh? So the problem now is if I were a hacker and I got hold of that table, I would sort by the password and I would look for repeating values. I would look for things that look like this. That now gives me a way that I could start and say, okay, they're not doing anything special. If I don't have anything, extra on here that each user has that's unique for them, I know that at least 2 or 3 people are using the same password. So what do we do to combat that? Well, one of the things, and Microsoft did this in some of their later versions, is they would generate a random salt value. And then they would store that, which I thought was kind of moronic, but they actually stored that hash value where? Okay. Actually in the database, didn't they? Okay. So I believe they were using some other, machine thing. I'm not certain on that. I can't remember which way they did it. But anyway, but here's the thing. You do need to have some sort of other value. And even if it's, another value and you do store it with your user information there, that's fine. It's still just one more piece that now means that everything now looks different. So here's what we're going to do. Let's go ahead and run this again. And I'm going to show you what we're going to do. So we're going to hash it. But now what I'm going to do is I'm going to call this other method that I wrote called generate salt. So Microsoft has added now this RNG crypto service provider. Look at line 39 there. Okay. Now I'm going to pre-allocate a byte array here of 64 because the RNG crypto service provider needs to fill up a byte array of 64. So I'm going to create a new instance of this. And then I'm going to call get bytes on this random number generator. And it's going to fill up this key, okay? And then I'm going to take that key, which you can see here has been filled up, and I'm going to convert it to a base 64 string. And now we'll be able to see what this looks like. If I hover over this, okay, we can see what this looks like. I thought I made that. I apologize. I thought I made that look a little bit larger there. Let's do a word wrap there. All right. So this, as you can see, is now some real gobbledygook. Yeah, that's a technical term. All right. So now what can I do? Well, now I've got another method that says I'm still going to take that value password. But now I'm going to take this randomly generated salt and add it onto it. So here's the thing, right? Now, when I create this and I compute the hash, look what I'm doing. I'm adding the salt to the beginning of the value. So now what happens? That now, as long as I have that salt value, now I'm going to get something different every single time. I'm going to hit F5 here. Okay, so there's the original one. There's that salt value that was randomly generated. This is now the new one. Okay, so even if, and you know, I mean, I agree, Microsoft has to store this information somewhere, right? Okay, so they stored it in the table. All that does for a hacker is say, okay, well, yeah, there's some other salt here, but they at least will not be able to identify patterns because everybody's going to have a different salt, which makes this completely different. Okay, watch this. Let me change this to just a 1. Okay, oops. I'm going to change this to a 1 if I can type. My gosh. Okay, and then let's run this again. So now when I look at that, there it is. Okay, in fact, I'm going to do this. Let's do this. I'm going to take a screenshot here. Okay, and so I've got a screenshot that we can look at. But now let's go back and let's just change this from a 1 to a 2. We're just going to change something really simple. Okay, and then let's see what happens. Actually, let's just go ahead and run it. Okay, so now look at that. Completely different. Look at this one starts with BLI. That one starts with 25U8. Completely different. So even the smallest value difference, okay, is going to help make these things be more secure. So the point here is always add a salt. Whether you generate it or maybe you've got a user ID, why not take that user ID and add it to that to their password value? Their user ID isn't going to change, right? Hopefully it doesn't. Okay, if you're kind of deleting users and maybe re-adding them and they get a different value, that could be an issue. But maybe that's another thing that you could do instead of doing a random generator. But if not, at least do the random generated. Store that because everybody's salt will be different. This will at least avoid repeating patterns. All right, so I hope that made sense. Now, here's what I want to do, though. I'm going to show you one other thing here. Okay. I'm going to make this a little easier. So, because here's the thing. I already mentioned that there were other algorithms you could have used, right, for this hashing. So, on this one, I hard-coded the SHA-256. So everything in here is completely hard-coded. Not really what I want to do. So what I did is I created a hash helper. So, John, this is where it really becomes easy because what we're going to be able to do now is another sample that I'm going to now show you. Okay. And inside of here, take a look at this. So now I'm going to do hash helper.instance.hash, and I can pass in an enumeration of what hash type I want to use. You want to use 256, 384, 512, just pass in the enumeration. Nice. Okay, and then you can pass in a value, and you can also optionally pass in a salt value as well. Okay, and then this will bring you back your hashed value. And then I can also do this. I can also have it generate a salt value for me. Okay, or you could just, maybe you have one around, but then you call the same thing here. And you can pass in the value and the salt value. Now let's go ahead and run this first, and then we'll go and we'll take a look at the code that I wrote. So same thing like you'd expect, right? Here is the kind of just password by itself with no salt. Here's then generated the salt through this hash helper class, and then there again is a completely new version of password hashed. All right, so let's now take a look at how this works. So the hash helper. First off, I like creating a singleton pattern. I try to avoid static classes. This is just me. Okay, I like to always have a class that I can create as an instance or that I could actually make a singleton. So I add an instance property on. Now this is a very simple way to do a singleton here. There's a better thread safe way. You can look that up. That you might want to use in a production application, but this will do for now. This will give me an instance If I first attempt to get the instance property and it doesn't exist, I'll create a new one and return that. I then have an enumeration here, and it just simply has my hash types that I can use. I then have a method called getHashAlgorithm. And what this does, you pass in one of those enumerations, and I will use the appropriate factory to create an instance of that particular one. Notice I'm using hash algorithm, not using SHA-256 or SHA-384. Each one of these inherits from the hash algorithm. It's their base class that they, and it's actually a sealed class, right? So it's or excuse me, not a sealed class, but it's a class that has to be derived from. All right. So I generate whatever one based on the helper, the hash type that you pass in, the enumeration. All right, so let's go ahead and run this, and we'll take a look at how this works. So here we are in this line of code where I'm going to do hash helper.instance.hash. So if I hit F11, all right, I'm going to go in here. I passed in this type as SHA-256. I passed in the value, that PAT SSW0RD, and I passed in no salt. So the first thing I'm going to do, if I don't have a salt value, I'll just make sure that it's string.empty. It was anyway, but if I passed a null there, I was just making sure. And now I do hash algorithm. That's the base class. Algorithm equals get hash algorithm. So I call that little kind of my own version of a factory method here, right? That says, okay, you said 256. I'll give you back a 256 algorithm. And you can see this right here. Okay. All right, so now I do the compute hash, passing in any salt and the value. I mean, the rest of this code is exactly the same as it was before. Very easy. And there we go. I get that. I also have the generate salt method in here as well. So I use that same code that we saw before. But isn't that easy? That's now a very simple way to do hashing. Okay, then you can see the values here. So a little hash helper class. I mean, look at that. It's like 100 lines of code, nothing. And that makes it, I think, very easy to do hashing with the three most popular hashing algorithms, 256, 384, and 512. All right. How are we doing out there? I'm not checking the chat window, so I don't know if anybody's asking any questions. It doesn't look like they are. So if you did, anybody have a question, I'll pause here on hashing. If anybody has a question on hashing. Otherwise, I will just keep moving forward here. All right. So let's go on. All right, now let's talk about symmetric encryption and decryption. So this is where if you encrypt something, you can decrypt it. You can get the value back. On this one of the most popular ones to use today is AES. That's the Advanced Encryption Standard. As I mentioned, there were quite a few others as well that you could use. AES is an abstract base class. Okay, so just like that hash algorithm was an abstract base class, it has to be derived from in order to be used. So Microsoft created an AES CNG, right? A wrapper around their cryptography next generation. They have AES Crypto Service Provider, the wrapper around cryptographic application programming interfaces. AES Managed, that's the one that uses all managed code. Okay. So what happens again when you use the create, right? It's going to attempt to retrieve the most secure algorithm from the machine. The most common default when you're running on Windows is going to be the AES Crypto Service Provider. That's going to be the one that the create method will give you back most often. Now, we need two pieces of information in order to encrypt some data. You have to have a key, and that key, you got to keep that key secret. And we need an IV, which is an initialization vector. And this is just a set of characters, kind of like our generated salt value, right? that's used to start the encryption process. So the IV can actually be made public because without the key part, it's actually worthless. They can't see it. Okay, there's, again, nothing they can do. Kind of like the salt value really could be made public, if you will, in the database, even though I'm not a big fan of that. I kind of think it ought to be stored somewhere else, at least in another table. Okay, at least let's not make it easy for the hackers. That's just me. Microsoft felt it was perfectly secure, and they've got a lot of people that are a lot smarter than I am, so fine, I'll bow to them. But anyway, the IV can be made public because it's, without the key, no one can do this. All right. So now let's take a look at how this one works. So again, I'm going to go through the same thing. I'm going to show you kind of the basics of using this, and then I will show you a helper class. But the first one, the Symmetric view model class that I created here, I have some properties. I have a key. I have our initialization vector, our IV. We have encrypted value and decrypted value. I kind of want to be able to see the encrypted and the decrypted value. So I'm going to hold on to that. Okay. Now, I do actually have a method here called generate key and IV. So in this one, on line 32, I'm doing a using, right? So, because again, why do you do a using? Because if you were to then look at this, you will find it has a dispose method. So anytime there's a dispose method, you better be wrapping this thing up into a using statement, folks. All right, so we're going to do a using on AES.create, and it's going to give us back this abstract base class in algorithm. And then when it creates it, it will also generate a key and an IV for us automatically. So these are two properties that have already been filled in. All I'm going to do is convert those to a base 64 string, and I'll store them into those properties, those public properties I created. To encrypt something. Okay, now let's actually go ahead and we'll run this and walk through this so we can see it happen. All right, let's go ahead and run this. So there's our key and there's our initialization vector. All right, so our key and our IV. Now let's step here, okay, and then we're set a breakpoint there, and now let's go ahead and uncomment some lines of code and let's walk through it. Now we create an instance of our view model. We generate the key and the IV, so we can see that these got generated, and it'll generate unique ones every single time you run. We spit those out. So now to do an encrypt, I need to have these three pieces of information to be able to encrypt the data. I need to have the value I'm going to pass in. I have to have the key and the IV. So I'm going to pass those to this encrypt method. So here they come. Those are my values. Okay. Again, it works with byte arrays. It's going to fill up this byte array with the encrypted value. Okay. So now, even though I'm going to create an instance here, and I told you that it creates the key and the IV, it's fine. If I've already got one, I can no problem just overwrite the ones they've already got. Okay. So now I'm going to do a convert from base 64 string, right? So this method will convert this into a byte array because that's what this key and IV needs for the algorithm. And now what we need to do is we need to do algorithm.create encryptor that you see here on line 53. And you pass to the encryptor the key and the IV, and this gives you back an iCrypto transform. You know, this is obviously an interface, but if we were to look at it, you'll see it's a universal crypto encryptor. That's a, boy, say that 3 times fast. Universal crypto encryptor. All right, so that's what comes back from this one. Now, again, if there's other algorithms, there's other create encryptors, they may actually have a specific instance of a crypto transform. You don't know, so always be safe and use the interface version of this. We're then going to create a memory stream. A memory stream also has a dispose, so we need a using. I'm then going to create a crypto stream, passing in the memory stream, my encryptor, and what I'm doing. I'm writing, okay, the mode, right? So what mode am I doing? I'm writing. I then have a stream writer, because I'm going to use the CS is a stream, so I want to use a stream writer so that I can write to that stream. And what am I writing? The encrypted values. So now the encrypted values are in the memory stream. Okay, we create a crypto stream to say this is the algorithm and where I want to put it. I want to put it into a memory stream. And then we use the stream writer to write that value into the memory stream, right? The encrypted value. So now what I'm going to do is I'm going to get back from the memory stream the array, and there is now my encrypted value expressed as a series of bytes. Again, do your clear on the algorithm, and then grab that byte array and convert it to a base 64 string. That can be now what we might store in the database. And then I'll go ahead and run this, and we can see that now the encoded value password using that specific key, that specific IV, is this encoded value, this gobbledygook here. That's what pay at SSW0RD looks like when it uses the AES algorithm to encrypt. All right. Well, if you encrypt something, it might mean that you might want to at some point decrypt something. To decrypt it, right, you still have to have the same key and the same IV. All right, so without those, the data is worthless. Now, if you lose the keys, you've lost the data. There's going to be almost no way that you can get that back. All right, so let's step into this. We get the key and the IV, we encrypt the value. So we now have the data encrypted. So now I'm going to decrypt by passing in our encrypted value, our key, and our IV. Pass that in. So we're going to take the value, we're going to create a byte array out of it. Okay, so now that's our encrypted value. So we put it back to what it looked like, you know, when we were doing the encrypt. We now use the AES.create to get us our algorithm. We assign the key and the IV from our key and IV that we use to encrypt it. We still create an iCrypto transform. We still create a memory stream. None of that has changed. But now when we create our crypto stream, we're now doing it for reading because we're going to read, right, the encrypted value in our memory stream. Look at this. I put into the memory stream, right, our encrypted value. So we're going to read this. And the stream reader now says, let's read it using that crypto stream to do the decrypt portion. Okay. Oh, I apologize. On line 93, I forgot to point this out. I'm not doing a create encryptor. It's a create decryptor. Right? That's how the crypto stream knows whether it's doing a decryption or an encryption. So create decryptor. I apologize that I glossed over that. All right. Using the stream reader, we're going to read now from that decrypted stuff, right? It's going to put it into our decrypted value, and we can now return that, and we can then see our decrypted value is indeed password. Cool. All right, so we've done an encryption, we've done a decryption. Now, that one was a little hard-coded, okay? So this, you know, I only use the AES algorithm here. It was all hard-coded here in every place. So instead of doing that, let's build our own symmetric helper now. Okay, in this symmetric helper, what we're going to do in this guy, so I've got a couple of constructors. So if they don't give me a crypto type to use, I'm going to default to AES, or you can pass to the constructor an enumeration. All right, and the enumeration, if we look down here, has all those different algorithms. Remember, those were the ones that I had on the slide. Okay, so we've got this enumeration of AES, DES, RC2, Reindl, triple DES. Okay, all right. So I pass that into the constructor, or I also, as we'll see in a minute, have a property that we can set. I'm also doing this as, you can do it as a, you can create an instance of this helper, or you can do it as a singleton. Either way works. Okay, I do have a public property now for the symmetric type here. I also have the values for key and IV, the encrypted value and the decrypted value. Okay, we saw the enumerations that I can use. All right, and then I have a few methods. I have a get symmetric algorithm, very similar to what I showed you before on the get hashing algorithm. You pass in the enumeration. I will call the appropriate constructor, right, or the appropriate factory method, this create method on AES or on DES or on RC2 or on Rindle or triple DES. And each of these inherit from the abstract class symmetric algorithm. All right, so there we go. We've got that method. And then we have our generate key and IV. Okay, so there we go. We've got, you either pass in the original, whatever the property is set to, or you can pass one in yourself, right? So a couple of overloads on this guy. And then I have encrypt and a decrypt. All right, let's go ahead and run this so we can take a look. All right, so I'm going to set a breakpoint here now, and let's run this guy. So we're going to create an instance of our symmetric helper. I decided to create an instance this time. Remember when I did the other one, I did the hash helper samples. I didn't create an instance. I used the instance property. I'm just showing you, you can do it either way, any way you want. Okay, so I'm going to create an instance this time. So that means it's going to default to the cryptography type AES. So now when I generate the key in the IV and I don't pass in anything, okay, it uses that AES. I should have gone into that, sorry. Let me go back here. There we go. So remember I set that in the constructor, so that one's now set. So now it simply goes in here, uses that symmetric algorithm, and gives me back the key in the IV. Okay, so we can see then what this looks like. Those are our keys and our IVs. Okay. All right, now let's go down here and uncomment a couple more lines. So now let's go ahead and do the encrypt. Now, if we look at the encrypt, I've got a few different overloads on this guy. Let's take a look. So I can pass in a value, and if I do, I'm assuming you've already got the key in the IV set. You can pass in the value with the key in the IV. You can pass in enumeration, the value, the key, and the IV. This is the one that then has our concrete way of doing things. So let's go ahead and run this. Create an instance, generate our key and our IV. Okay, so again, if we were to look at this, and actually we didn't step into this before, but you know, it's going to pass in our type here, which is AES. So it goes through this switch statement. It does the AES.create. So we now have an AES implementation. Okay, so we get our key and our IV now set. We spit them out. Then when I do the encrypt here on password, okay, since I've got an instance of this, right, I don't need the key and the IV. So if I step into this, we can see that I'm going to use the key and the IV that we just generated in the previous call. So we come down here, and now this looks exactly like what we had before, but now I'm just more generic, right? I'm passing in the type I want to use. We do the AES.create, but instead of hard coding the value here, right, where I was doing the AES before, now it says, hey, this is the generic symmetric algorithm. So you can pass any one of those you want. All right, so now we get set our key in our IV. We do our crypto transform. We do a create encryptor. We do our memory stream. We get our crypto stream. We have the stream writer write from that crypto stream that value. We grab the converted to bytes. We clear everything. We get the encrypted value back. And we can now write that out. And there it is, password again, using that key and that IV with AES looks like this. Now, before I go on and do anything else, let's go do this. Let's actually pass in a different one. Let's use Rindle. Okay, so I'm just choosing anything at random here. So instead of using AES, let's take a look at what this now looks like. And I'm not going to run through it. I mean, we just saw the code, but I'm going to hit F5 here. Okay. So the key and the IV, these could be different lengths. They could be different, you know, probably they do look different. Okay. But each one of these that you do could have potentially different length keys and IVs. It could be different values that spit out. Okay, there we go. So DES, you can see the key and the IV are much shorter. Now, if they're much shorter, what does that mean? Yeah, that it could probably be hacked a little bit easier. Okay, so we saw AES looked pretty good. Rindle looked pretty good. Let's try triple DES. And if you're figuring that this is triple of DES, well, you're right. So obviously we're back to a nice long key, you know, a good size IV, and there we go. So each one of these can be used. It's just up to you, right, what you want to use. This is easy, guys. Very simple to use these algorithms now. I'm hoping at the end here, John's going to say, wow, Paul, got it. That looks great. So, all right. Now let's go ahead and do the decrypt. So I'll set a breakpoint here. All right, so our view model, right, if we were to expand this out, and we can see we're using the crypto type AES. We've got our encrypted value, we've got our IV, we've got our key. Okay, so we're going to now pass that into the decrypt. I'm going to use the F11 key here. And here we go, there we go. So we got the value, right? We've got our key, we got our IV. We do the get symmetric algorithm. We set our key and our IV. We now do the create decryptor. Create our memory stream with our encrypted value, the crypto stream, using our decryptor, telling it to do a read. We do our stream reader, and that gives us back now our decrypted value. And we go ahead and run this. So now we can see that we encoded the value. The encoded value becomes out this. We're now decoding the value, which is the one that was encoded, and it comes back as password. Whew, all good. All right, so we've covered hashing. We've covered the symmetric algorithms. I'm not going to do asymmetric. It's very similar to what I just showed you, and there are some good samples up there, so not going to go through that one. But let's take a look at one other thing here, and that is key management. Okay, key management. So how do we manage these keys? Because as I said, right, if you've got a key and an IV, we need to keep that key secret. So what do? You know, where do you put these keys? Well, there's a few different ways to do it. I mean, there's actually things that you can do with Azure. Azure has a key storage vault. So you could use Azure to store your keys. The thing that's nice about using Azure, it's in the cloud. Okay, different machines can then access and use the same keys. So if you're encrypting things in a web farm, right? For instance, right? You got a web farm, you're going to want to make sure that they each have access to the same key. Because what I'm going to show you is using the data protection API, the DP API. The problem with the DP API is it's only valid for that machine. The key is only valid for that one machine. So I want you to think about this a minute. Let's say you have a web server. You use that web server to store the key that you use maybe to, encrypt the user password. If that machine dies and you have to completely get back a whole brand new machine with a whole new instance of Windows, guess what? Windows will create a different key set for the DP API, which means your keys are now invalid. Okay. Or again, if you had 5 machines in a web farm and user 1 comes in and gets his data gets encrypted and put into SQL Server on this machine, but then the other user goes to machine 2, his uses a different key. But then what happens? It's a web farms, right? So he uses some round robin. User 2 comes back. He doesn't go to machine 2. He gets routed to machine 4, and we try to decrypt, different set of keys. So use this with a grain of salt, okay, as far as maintaining keys. This is one way to do it. There are many other ways. I didn't want to have to, again, I didn't have enough time to go into all the various ways, but do take a look at the Azure Key Vault. Okay, that's a great way to handle things these days. All right. Now we're also going to use the protected data class to protect and unprotect memory. All right, so again, I want to keep things secure even in memory now. So I'm going to use this protected data class. And I want you to note, because you're going to see a little warning. I made sure my warnings, I didn't turn them off in Visual Studio. I'm going to get a warning on these particular methods because they are for Windows only. Remember, cross-platform, right? So if you're running on Linux or if you're running on Mac and you're doing this .NET 5 app and you're trying to run it over there, the protected data class is not going to work on those. But our goal here is to store or create a good version of the key, right, that's encrypted, and store that encrypted results in a file. All right, let's take a look at how we can do this. And again, this is just one way, people. So now what I've done, I didn't bother having a view model here. I just did a storage helper for you. So let's take a look at this now. Key storage samples. Okay, and I've already got my breakpoint set. Wonderful. Actually, let's go ahead and set it here. Let's take a quick look at this key storage helper. I've done a singleton again, so I can use it as a regular, just create an instance, or I can use a instance property of it. I have a save method, and here you can see the little squiggly. This call site, okay, this method is, this one happens to be reachable on all platforms. Okay, so this is a warning that this one is reachable. Okay, but I've seen this before. I can't remember. Maybe it wasn't this one. Was it? Okay. Well, it's nice it's giving you a warning. You can turn these warnings off. Just thinking, oh, you know what? It was another sample I was doing. I apologize. This one's okay. But what's nice is it is actually telling us that these types of things may or may not be reachable on all platforms. Okay. Oh, no, this one, I'm sorry, this does have the method. Okay, this is, that's right, I remember this now. Most confusing here, isn't it? Because it says this call site is reachable on all platforms, but protected data.unprotect is only supported on Windows, okay? So what I think this means, and it's so weird, I think they mean call site means this actual guy here, the protected data class, but this method is only available on Windows. Most confusing method. That was the thing I forgot. That's what I was pointing out. Sorry, guys, I haven't taught this in a while, so I've forgotten the stuff. I think I taught this last time about, I think it was beta of .NET 5. Okay. So let's walk through this and take a look. Let's go ahead and run this. All right, so we're going to create our symmetric helper just like we did before. We're going to create our key storage helper now. And I'm setting the file name here to cryptosample.dat. All right, so that's going to be the file name that we're going to store in. Okay. All right, so now we're going to generate our key and our IV. We're going to encrypt the value. Okay, and now what I want to do is I want to save, and I could store the IV, I could store the key, whichever one you want to save out there is fine. I just did the IV. Again, I think I changed this around last time I made my sample. So I'm going to store this IV out here like so. All right, so where does this get stored? Well, if we go over here to where I'm running this sample, okay, under under bin, debug, .NET 5. Okay, here we go. Cryptosample.dat. If we were to open this up, there is our IV encrypted, okay, into that file. Pretty cool. All right, so now we've got that stored. So I'm going to wipe it out. And just to show that, I can get this back and put it back as my IV. So I did the encrypt, but I haven't done the decrypt yet because I wiped out the IV, but now I've got it back from the file. So now if I've done everything correctly, if we let this run, everything still works, right? We encrypted it, and then we decrypted it, and we got back to where we were. All right, so let's take a look at how this works now. So let's look at the save here. Passing in the IV or the key. Okay, so I've changed the IV. Really, you could do either one. Who knows which one we're storing, the key or the IV? It doesn't really matter. But all I'm going to do is I'm going to take our key. I'm going to get a byte array, and then I'm going to use this protected data.protect to say, okay, what I'm doing is I'm using this data that I've gotten from the key, and the data protection scope is the current user. Now, this could also be the current machine. So in this case, I'm actually doing it for me particular logged into this computer. So the keys it uses to protect this, because the protected data is our DPAPI class, okay? What it's using to protect this is my current user keys. So you don't need keys or anything, because remember, this is built into the machine. For my user, I've got my own particular sets of keys, and then we write that out, whatever that is. Okay, and then when I want to get it back, I do the protected data unprotect. Okay, again, passing in the data. So I've read all the data now from the file. I read all the bytes in, and now I'm going to unprotect it. Okay, and then get back that string that I'm expecting, which is great. Okay, that's what we want. All right, now let's go back here because I want to show you some other things, right? I did data protection scope.current user, but I could also do the local machine. Okay, so if I use local machine now, and by the way, if you're going to do unprotect with local machine, what do you think you got to do over here? Yeah, you better do it the same, because otherwise it's going to be, right, two different keys. One for the user is a different set of keys than the local machine. All right, let's go ahead and run this now. So now we save this out there. It still works, but we go out here and we look at this DAT file here. Okay, I should have saved the other one, but if you were to look at this, you would see that this looks different than the other one I had. Okay, because the other one was the current user scope, whereas this one I used the local machine scope. All right, so pretty easy though. So if all you're concerned about is a single machine, you got a small website that you're running on a on a single web server, and you want to have some keys stored, you can use protected data. That's your DPAPI, okay, and use protect and unprotect to actually encrypt things. Or maybe you're on a WPF app or a Windows Form app and you wish to store some things securely on that machine. Okay, this would be a great way to do this. Okay, now do know that this particular one is only supported on Windows. Okay, so you do want to check these things. And again, they are very confusing sometimes. You need to kind of read the whole message. So you can see even I get tripped up on some of this stuff. All right, great. So I know we're coming up on our time here, but that's fine because I'm at the summary. All right, so hopefully, we've seen that this is pretty easy. Hashing is our one-way algorithm, one-way algorithm, sorry, typo. Salting, definitely a best practice, folks. Make sure you're doing salting. Asymmetric algorithms allow you to encrypt and decrypt. Need to work with public and private keys. Symmetric algorithms also allow you to encrypt and decrypt, and you'll need a key and an IV, which is very similar to the public and private key concept. All right, and again, think about key management. All right, you can use DPAPI, but as I said, these days, everybody's connected. I would seriously take a look at the Azure Key Vault as a way to handle this for multiple machines, okay? All right, so only use DPAPI really if you're kind of in an offline scenario. All right, well, before I move on, any questions up to this point, guys? I mean, anybody have anything? Hopefully everybody's still with me here and they're,
You're just making it a little too easy, Paul.
All right, good. Hey, that's it. That was what I was hoping for.
Your samples are really good. They're very straightforward.
Right.
And there was one question put out there, but someone more or less addressed it. I don't know if you want to check the chat.
Ah, okay. Yeah, I can do that. Well, before I do that, let me say, I got a whole bunch of Pluralsight videos out here. As you can see, a lot of them on .NET. As we all know, our good friend and Scott Allen passed away last year, or was it actually a year and a half ago now, I think, wasn't it? It's been a while. He was a great guy. I mean, I knew Scott very well personally, wonderful guy. And so unfortunately, a lot of his courses now on Pluralsight are coming up for renewal. I was very honored to be chosen to do his Link course. So brand new, I just released it about 2 weeks ago. So C# language integrated query Link is brand new out there. I also have implementing ADO.NET with C#. I have some XML stuff, lots of things out there. I've done a lot of front-end web technology stuff, interacting with data using jQuery and Ajax, JavaScript, REST APIs. If you're interested in like Node and getting a Node REST API going, that's what this one is. So it's all using JavaScript, everything, 100%. Geolocation, lots of stuff I've put up there. Some Angular courses. I'm redoing the Angular security one. That should be up in the next couple of months here. So I'm doing an update to that because the last one I did was Angular 6 and we're on what, 11 now. So, but as you can see, I've done a ton of courses up there on Pluralsight. So when you get a chance, go up and check some of those out. I'm still putting my daughter through college. Oh, this is her last year of college. She'll graduate in December, thank God. So then the bank of dad closes. Woohoo! All right. Sample code. So as John said, I had a lot of great samples there. They're all available for you. Just go to pdsa.com/downloads. Go to the user group presentations, and you'll find yours there, the St. Louis user group with the cryptography samples, and it'll lead you to my GitHub where you can download those and then have fun with them. Check out my training on Pluralsight. Just do a search for me up there. You'll find me pretty easy. If you have any mentoring, training, or consulting needs, I am available for that. psheriff@pdsa.com. So go ahead and feel free to hit me up there as well. But other than that, let's see. Let me get back out of here. I'll stop sharing. And then, yeah, so she said somebody did have a question. What about Argon 2? It's claimed to be the most secure? Oh, yeah, somebody did answer that. Yeah, so now that's the other. I should have even said that. I appreciate Tojo, is it? Or Toyo? I apologize if I mangled her name, but that is something. A lot of times, obviously, you can go out and look for NuGet packages that you can bring in to .NET for some of these other algorithms. So a lot of people have put a lot of other stuff out there. There's always somebody claiming to be more secure than somebody else. And then, of course, 2 years from now, they'll all be obsolete anyway. So, and we'll be doing something different. But this is why I encourage you to use something like my helper class, because when you want to add something, all you have to do is add a new enumeration, right? That's literally all you'd have to do, that new enumeration. Then in my get algorithm type, that guy there, that method, you would simply add a new case statement to call its factory, and boom, you can use it. So, and that's why, again, I think I've made it pretty easy here for future proofing this as well. So great question. Thank you. All right, John, I'm going to stop there. I appreciate everybody attending tonight, and thank you very much. Hopefully I'll get back there to St. Louis and see y'all in person someday. So thanks for having me, John.
Yeah, Paul, this was great. And your samples, like I said, are very straightforward. And every time you give a talk, your samples are great. So really appreciate your time tonight.
Absolutely. Thank you.
All right. So thanks everyone for joining us. Take care, everybody.
Bye, guys.